So we're going to take that first derivative, x e to the x over x plus 1 squared, and we're going to find the second derivative. So I'm going to apply the product rule. So I end up with 1 times e to the x. Okay, I'm going to use a different color here. 1 times e to the x plus x times e to the x. And that's the product rule for the numerator. I still need to multiply that by the denominator and then apply the quotient rule. So I end up with x e to the x, and then applying the power rule here, I get 2x plus 1. And then in the denominator, I'm going to end up with x plus 1 squared to the power 4. Now, it's really important that we simplify when possible. So I'm going to make a note of this. So simplify when possible. Okay, because these expressions can look pretty messy looking. So I'm going to cancel the common factor of x plus 1. So I have 1 in each of those terms there, and then I'm going to multiply that all out and combine like terms. So expanding this all out, I get x e to the x plus x squared e to the x plus e to the x plus x e to the x. Okay, and then this is minus, since that all cancels out, so it's going to be 2x e to the x. Now this is way easier to do than if I had that extra x plus 1 term in there. So again, it's really important that we simplify when possible. Now, nicely, what happens here is I have an x e to the x, an x e to the x, and I have a minus 2x e to the x. These all cancel. So I'm left with then, in my second derivative, e to the x squared. Sorry, I'm going to go x squared e to the x plus e to the x, and that's all over x plus 1 cubed. Factoring that, I get e to the x squared plus 1 all over x plus 1 cubed. Now I want to know when this is equal to 0. The e to the x is never equal to 0. Okay, so there's no solution here. And furthermore, that has no solution. So this says these both have no solutions. So there's no solution to this equal to 0. However, I still have my restriction in the denominator at -1. So at -1, I have my undefined second derivative. So I still do need to test on both sides of that for concavity, although I can kind of see what the concavity is going to look like here. Okay, so the concavity of this is going to be f double prime at let's try -2. F prime at -2, that's going to be positive for the e to the x, positive for the x squared plus 1, and then it's going to be negative for the denominator. Okay, so that's going to give us negative concavity. So that looks like, is that right? Yeah, that's going to be negative concavity. So we're going to have negative concavity through here. So as I draw my graph here, it's going to have negative concavity through here, connecting those asymptotes like that. Looking at the other side of that, looks like it's gonna be positive concavity, but we should check. So at the derivative at 1, if I plug in 1 into that expression, I'm gonna have positive for e to the x, positive for x squared plus 1, and then positive for the denominator. That's gonna be positive concavity. So putting my positive concavity in there it is. And then the rest of the graph's going to look like this. It's just going to come down from the asymptote. That is a minimum. And it's going to go off to infinity. Okay, so there's what the graph's going to look like. And we can kind of check this on uh, Desmos as well. Now I don't have any other coordinates actually to work with here. These are the only ones. I might want to put in my table here at -1, I have a vertical asymptote.